Hello, my name is Divya Vanessa Prakash, and my metric number is B0821101148. So, I would like to explain about my part, which is introduction. Introduction A is explain what the application is all about, explain where the control is being used, and the calculation of steady state error for step input, RAM input, and parabolic input. So first of all, the introduction is the title of this process. The title of this report is temperature control system for industrial. So for temperature management is essential for industrial process because it helps to ensure the product quality, improve the product effectiveness, and preserve worker and equipment safely. So the installation of a reliable temperature control becomes crucial to achieve these goals. So such a system provides real-time data analysis, automation capability, and integration with current industrial infrastructure in addition to monitoring and controlling the temperature. So the temperature control system for industrial application is intended to provide precise and trustworthy temperature management. So as we know, as the temperature monitoring system uses a network of temperature sensors that are deployed strategically across the industrial setting to record the temperature measurement in depending on the needs. These sensors can be deployed as stand-alone unit or incorporated into the current infrastructure. So A, what is the application is all about? So this temperature setting is different industrial process, equipment, and environment is known as a temperature control system for industrial applications. So in order to ensure product quality, operational effectiveness, and worker safety, it makes sure that temperature sensitive operations are carried out within ideal temperature ranges. So make sure this process must be operate with ideal temperature ranges. So temperature control systems can benefit from variety control system design and analysis tool provided by MATLAB. For this whole process, we will use MATLAB. So analyzing system stability, response characteristic, and robustness to shocks is possible with MATLAB control design tools. So to obtain the necessary temperature control performance, design iteration might be carried out. So using hardware interfaces like data acquisition, or program logic control (PLC), MATLAB facilitates the construction of real-time control system. So where the control is being used. So these control are required temperature condition. So these controls are applied at several stages and components in the temperature control system industry. So temperature sensor that gauge the system's process present temperature serve as the foundation for control. So this temperature measurement that these sensors offer are continuously monitored by the control system to ascertain the temperatures, ascertain the system state that the moment. So next, the controller is the system's main building block, as we know, for the controlling temperature. So the desired set point temperature is compared to the data it received from the temperature sensor. So the controller creates a control signal that says specify how the temperature should be changed based on this comparison. So to determine the proper control signal, the controller may employ a variety of control methods, including proportional, integral, derivative, which is PID control. So this temperature sensor, controller, actuators, and process itself make up the feedback loop. So the control compares the measured temperature to the set point using the data from the temperature sensor. So next I'll explain about the calculation of steady state error for step input, RAM input, and parabolic input. So this is the transfer function of this whole process. For step input, the Laplace transform of the input is 1 over s. So if the limit approaches 0, so the answer will be 3 over 50, which is 0.06. For RAM input, the Laplace transform of the input is 1 over s squared. So the limit approaches 0. So the steady state error for a RAM input is 0. If the parabolic input is, the Laplace transform of the parabolic input is 1 over s squared. So if the limit approaches 0, the answer will be for the steady state error for parabolic input is also 0.
My name is Naisha. I will talk about my part, which is C. Draw the block diagram for the application and state the input, output, and feedback of the applications. So this is the block diagram. Next, I will explain input, output, feedback. First input, the input to the system is the set point, which is represent the desired temperature for the industrial. It is the target value that the control system aims to achieve. Next is output. The output of the system is the actual temperature inside the industry. This is the physical quantity that the control system is responsible for regulating and maintaining at the desired set point. Next, feedback. The feedback is the system is obtained from a temperature sensor located inside the industry. The temperature sensor measure the actual temperature and provide feedback to the control system. Next, my part is D, model the system to get the system transfer functions. So this is our model. First is step input. Next is summations, gain, transfer functions, and scope. This is our designs. So this is my last part. E, calculate the peak time, settling time, percent overshoot from the transfer function. From our transfer function, this is our transfer function. Firstly, we calculate omega. Omega that we get is 7.0711. Next is zeta. Zeta that we get is 0.4950. Then first we calculate TP, peak time. Peak time that we get is 0.511. For the settling time is 1.143. Then percent overshoot is 16.7%. Lastly, this is percent overshoot also that we get is 39%.
Assalamualaikum, my name is Nur Manisha. I represent F, G, H and I. For the F, we need to use MATLAB to get the system response. Step. Input is used as the system input. First, we define the numerator and the denominator. Second, then create the transfer function G equal to transfer function numerator denominator. Third, we can calculate the characteristic for peak time, settling time and overshoot. After that, label the title, X label, Y label, and it will be displayed the characteristic. Then for the result command window will appear for peak time, settling time and overshoot. Graph under them also will appear. For the G, we can compare the calculation and simulate result for peak time, settling time and overshoot. Next, for H from transfer function to state space representation. Its main model based fault detection and system identification. A state space representation is a mathematical model of a physical system specified as a set of input, output and variable related by first order differential equation or different equation. For the I, the stability assisted explained, we use RH table that Roth-Hartwig stability calculation is having one necessary condition and one sufficient condition for stability. If any control system doesn't satisfy the necessary condition, then we can say that the control system is unstable. But if the control system satisfies the necessary condition, then it may or may not be stable. So the sufficient condition is helpful for knowing whether the control system is stable or not.
Hi, my name is Mugilasan Anarakinadaraja. My Metric number is B08210088. Today I'm going to present about group assignment, which is discussion and conclusion. Now I'm going to share the slide. As you can see, this is our discussion. Based on the project we did, we focus on the findings and implication of the analysis of the temperature control system for industrial. This knowledge is useful for designing control strategies and turning system parameters. Temperature controls have several other parameters, one of which is a set point. Basically, a set point is a target value set by an operator which the control aims at keeping steady, as they prevent oscillation and maintain reliable temperature control. The calculation of steady-state error for different input signals, such as step, ramp, and parabolic inputs, allow for an assessment of the system's tracking accuracy. The temperature measurements that these sensors offer are continuously monitored by the control system to ascertain the system state. By comparing the calculation value and simulation value, there some minor error due to human error and procedure error. Now we're going to see the conclusion. In this assignment, we have learned about the function and the control system of the temperature and system for industrial. We also learned about the application on where the control is being used. We first explained the application, then drew a block diagram of the system, and finally modeled the system to get the system transfer function. Later, we also learned how to use MATLAB to get system response. We also have then calculated the peak value, settling time, percentage overshoot, and state space representation of the system. Finally, we have discussed the stability of the system and calculated the steady-state error for step, ramp, and parabolic inputs. This is our conclusion. Thank you.